Alright, in this video I want to show you how to do a particular problem that has to do with approximating a binomial distribution using a normal distribution. And this is a pretty involved problem, so let me read it to you and start filling in some data here. First of all, we are told that we have an aircraft, right? We have an airplane that can hold 211 passengers, right? 211 seats. So we have a total of 211 seats here. And on this, if you can bear with my picture here, on this cheesy little airplane of mine, that's not bad, art. Okay, so I didn't really go to school for art, but on this airplane of mine, in fact, airlines do this quite a bit. Airlines will, there's my door there. Airlines will often overbook a flight, quite often, so that if people do not show up for the flight, then they can almost be guaranteed that they'll have a full flight and make the most amount of money. Okay, so back to this problem. We're told that we can hold 211 passengers, 211 seats, and we're also told that when someone buys a ticket for this flight, the airline happens to know that the probability that someone will not show up, right, the probability that someone will not show for this particular seat or particular flight is 0.0672. Now what they're telling you here, actually, because this is a probability of somebody not showing up, is they're actually revealing to you the probability of failure. So I'm just going to set this thing here equal to little q. Since little p equals probability of success, little q equals the probability of failure. So knowing little q, we can also figure out what little p is, because we can just take this value, little q, away from 1 and come up with a probability of success being 0.9328. And again, I hope you see that these guys are complements of each other. Okay, so again, little p, probability of success of somebody showing up for the flight, is 93%, but the probability that someone doesn't show up for the flight is roughly about 6 or almost 7%. Okay, let's keep going. The other thing that they told us was that a booking agent actually overbooked this flight by 230 and by taking 234 reservations. That's pretty interesting. Now that's quite a bit more than 211 seats. They really overbooked this flight, didn't they? That might be a concern later on. We'll see. Well, those 234 reservations that they took is my n. Okay, that's my sample size, so I've got an n of 234. Alright, what they're going to ask us in this question is to find this. They're going to ask us to find the probability that we do not have enough seats. Okay? Probability that we don't have enough seats. Now, think about this for a second. If this cheesy little airplane of mine can hold 211 seats, what they're really asking for here is to find the probability that x is greater than 211. In other words, if 211 people show up, we're good. We're okay. We have seats for everybody. But if more than 211 people show up, we're not okay. We're not going to have enough seats. All right. So that's why I'm going to put this equal to, this probability of x being greater than 211. So I guess this is really my x value over here, isn't this? This 211 is really just an x. Alright, now, a couple of things going on here. Right? This is a discrete number. We're going to use the normal to help us find out what this probability is. That means that I need to do a couple of things. That means that I need to change this probability into something called a continuous data value, and to do that I have to use this idea called continuity correction. Okay, we got continuity correction going on here. And this concept of continuity correction is covered in a previous video that I have recorded, so maybe you can find that. So since I do not want to include 211 but greater than 211, continuity correction says this is what I'm really looking for. I'm really looking for x being greater than or equal to 211.5. That's what I'm really looking for. Okay? Continuity correction going on there. Now, I cannot look up 211.5 in a normal table. It just doesn't exist. So there's one other idea here that means I need to change this x into a z number. I need to change this thing here into a z number, and that I can look up on a table. Well, let's see. Do we have a formula to change an x into a z? Yes, we do. But before I even proceed with all this and do a bunch of work here, this might actually be useless for me. I may not actually be able to use a normal to approximate a binomial if two things are not true. So let me just start a new sheet here. Remember that in a previous video I showed you that there are two things that I need to check. Right? There are two things that I need to check. I need to make sure that my n times p, probability of success, is greater than or equal to 5. I also need to check that my n times q is greater than or equal to 5. Okay? So I'm going to do that real quickly here. I've got all of my variables. I've got my n, 234. I have my p, 0.9328. And I also have my q of 0.0672. There it is. So I'm just going to quickly double check all those things, and I'm going to do this very quickly here. 234 times my probability of success of 0.9328. And if you do that on a calculator, you'll see that you come up with 218.2752. Right? You can pause the video and double check that if you want. Hey, definitely bigger than 5, right? Definitely bigger than 5. So we're good here, okay? The other thing I should check is make sure that this 234 times my probability of failure, which is, let's see, 0.0672, is also greater than or equal to 5. And sure enough, it is. It comes out to 15.7. Wait, you can't see that. It comes out to 15.7, blah, blah, blah. It's got a big, long decimal. But hey, look, that's definitely bigger than 5, right? So both of those check out. Now listen, if one of these, right, just one of them, was not true, was not greater than or equal to 5, then I could just stop right there. The problem is done. It doesn't work. Okay? Can't use the normal to approximate the binomial. But both of those check out. Now the other thing, if you recall from maybe a previous video or previous problem that you've done, we have a formula to change, right? We have a formula to change an x value into a z value. So we need this formula. But I also need to know what the mean and the standard deviation are. Okay, well, let's see. Also covered in a previous video. There's your little formula for mean. Here's our formula for standard deviation. Okay, square root of NPQ. Hey, do you notice that n times p being our mean was already calculated? Yeah, we already actually did that up here, right? N times p, that's what we did to verify that it was greater than or equal to 5. This is actually our mean right here, 218.2752. And so all I really need to do is this calculation to find my standard deviation. All right, so let's go do that one real quick. Pull up my calculator. And again, the formula is the square root of NPQ. So I hit the square root button. Open up a set of parentheses here. And I'll multiply my n, which is 234, times my p, which is 0.9328, times my q. My q in this case is 0.0672. And I'll just close off that parentheses, hit equals, and look, I get a standard deviation of, I don't know if you can see that on the calculator there or not, but I get a standard deviation of 3.8298947, and that's enough. I'm not going to round any of this off. I'm just going to leave that there, and don't do any rounding until the very end of the problem if you're using your calculator here, okay? Okay, so to finish this problem off, here's what we've got. I've got an x value. All right, I've got an x value, and I showed you that earlier. Remember, our x value is 211.5, right? 211.5. Minus a mean. Hey, we've got the mean. That's the mean right there of 218.2752. All of that divided by this standard deviation of 3.8298947. 8, 9, etc., etc., etc. Now, this is just a calculator problem. I'm not going to worry about showing you how to do that. You can just figure out the difference divided by this thing, and it turns out that you should get a z-value if you do this correctly, and maybe you can pause the video again if you'd like and verify that you get a negative 1.77 if you round that number off to 2 decimal places. Okay, so that's the z-value that I have here, and I'm going to plug that in right here, a negative 1.77. Okay, and I've shown this on another video as well. What I'm going to do now is I'm going to look up negative 1.77 in my normal table. If you do that, you'll see that you get a value of 0.0384. Now that's not the answer. What I need to do is I need to subtract that from 1. Why do I want the complement? Well, look, this right here says greater than. That means shading to the right. When you look up negative 1.77 on the table, at least the one with this Triola book that I'm using, Elementary Stats 11th edition, it assumes that we're shading to the left. So this 0.0384 is actually shading to the left. I wanted shaded to the right. So I've got to take the complement of that. And I get a value of 0.9616. That's what I'm going to enter in as my probability of not having enough seats. Right? Probability of not having enough seats. This thing here, which we were asked for, was 0.9616. Now that's a pretty high probability. If that probability was, say, 5% or less, so 0.05 or less, then I'm not concerned about overbooking at all. But that's a pretty high probability. I think this ticket agent was a little overzealous trying to make the big buck and definitely overbooked this flight. Okay, the overbooking is definitely a concern for this problem.